Hi guys, and welcome to another tutorial, and today we're going to take a look at how we can implement texturing into our rendering system. So we're going to be creating a physically based rendering system, and we're going to create the first part of that today. So stay tuned. So we're going to start off by creating a new folder, and we're going to call this materials. And inside of here, we're going to create a file called texture.js. Then we want to import GLC. And we want to export a default class called the texture. Then we'll need a constructor. And inside of this, we're going to create a texture variable, and we're going to call glc.createTexture. So we'll create that function later on. Then we're going to call glc.bindTexture, and then we're just going to bind this texture here. Then we'll also create a we can call this define dummy texture, because this is actually going to be an asynchronous function loading in a texture from either a URL or a path on your computer. So we need to define a dummy texture because the rendering system will already be running. So we need a way to actually fill that blank spot when uploading the texture to the shader. Then we're going to create another function called loadTexture. And this will take in an URL or a path. And then we're going to create an image object, and we need to set an attribute to this, so image.setAttribute, and we're going to set the cross origin attribute to an empty string. Then we need an onload function, because this will be called when the asynchronous loading has been completed. So onload will equal another function in this class, so this.onload with this image object. And then finally we need to bind this URL to this image, so image.source is equal to this URL. Then we can go a bit down and we can create this onload function. And inside of here we're going to pass in the image, and we're going to call glc.bindTexture again to make sure this texture is actually bound. We also want to define a texture now, so glc.defineTexture with this image object. So now we're just creating a texture, setting some variables to this bound texture, basically. Then we'll need another function to determine if this texture is actually a power of 2. So if the sides are either 2, 4, 16, 32, and so on, we need to handle that differently from when it's not. So is power of 2, and this will take in the side of the image, and we're just going to call side and side minus 1. If that's equal to 0, then it's a power of 2, basically. So then inside of here we need to make this check here, so this dot is power of 2, and we're going to throw in image.width, and we'll need to do the same thing for the height. If that's the case, then we'll call glc.texture power of 2, and otherwise we'll call glc.texture no power of 2. Then we also want to flag when this is done, so this.done is equal to true. Then we want two more functions. One is to enable the texture for rendering. So we're going to call glc.bindTexture with this texture. And we need an arrow here. And then we also want a function to check if the texture is actually loaded. So texture, if this has texture, then we'll just return this done. Then we want to create another file, and we're going to name this material. and this will import the texture. It will also import GLC. Like that. And then we'll export default class called material. So in the constructor, we're going to say that this.diffuse is equal to a new texture. So this is the dummy texture now when we've initialized this material. And then we'll want the function to add a diffuse texture here. So add diffuse, and we'll pass in the URL here. And we'll call this.diffuse.load texture with this URL. And we can also return this so that we can nest functions later on, because we're going to add a lot of more textures in the future. Then we need a function to enable the diffuse texture. And we'll pass in the shader here. And we're going to call glc.activeTexture0, because you can have a lot of different active texture slots in WebGL. So basically, I think it's a minimum of 9, and then it can go up, dependent on your video memory. And then we're going to call this.diffuse.enable. And then we also want to upload a couple of ints to the shaders. So glc.uploadInts. And this will take in the shader.diffuse texture that we'll be creating in the shader later on. And we would just want to set this to the 0th active texture. And then we also want to upload a bool. Shader.hasDiffuse texture. This.diffuse.has texture, because we want to handle this differently if the texture isn't loaded yet. And then we want a final function called enable. So this will be the call that we will use outside this function or this class. So this dot enable diffuse is the only thing we need here right now, and we'll pass in the shader here as well. Then we want to go into our model type, and we need to add another set of textureCoords here, or another set of coordinates. So textureCoords, and we'll bind them. And then we want to create another buffer for these textureCoords. TextureCoord buffer, and we'll just pass in the texture coordinates here. And then we want to call these in the constructor. Then we also want another function here, which is going to be called add material, because we want to be able to add a material to this model type. And we'll just throw in the material. And we're going to set this.material is equal to material. And then we also want to create a new instance of the material here in the constructor, just for it as a placeholder, basically. So first of all, we need to import it. So import material. Whoops, material. And then we can just say that this.material is equal to a new material that's empty. Then we want to enable the texture coordinates here, so we can do that after the vertex buffer. So let's take this, so textureCoord buffer, and then we want to call enable textureCoords. And then in the end, we also want to enable the material, so this.material.enable, and we need to throw in the shader here. Then we can go inside our shader, and we're actually going to create the locations for all of these string variables here, because it's better to keep them in one place. So let's do that right now. So inside of our locations, we'll create a new one called transformation matrix. And we also had the light's position. paste that in there. And we had the light color. And the final thing was the light ambience here. There we go. And now we're actually going to add a compile status function so that we can see if we've received any errors from the vertex and fragment shaders, because it will be a lot easier to debug what the error is basically. So we're going to type compile status, and then we can throw in a shader here, and then we can say that if glc.gl.get shader parameter of the shader, and then we're going to call glc.gl.compile status. Then we want to console throw an error here and just say glc.gl.get shader info log of the shader. And then we want to use this right after the vertex has been compiled here. So this.compile status, throw in the vertex, and then the same thing for the fragment shader. And now we also want to use the locations here. So locations dot transformation matrix, and light position, and let's just do this, goes a bit faster. And we had the light color and the ambient. Now we need to define a new attrib location for the texture coordinates. So this .textureCoords attribute, and then we need a new location for that as well. So inside of here, let's say textureCoords and we can actually make this a camel case like that. And then we can take this and use it in here. And then we also want to define two more uniforms for our diffuse texture. So basically that was the int which we uploaded. So this.diffuse texture is equal to this function here. And we'll do the same thing for the has diffuse texture bool that we uploaded. And then we'll need to create two more locations for these. So that will be diffuse texture and the has diffuse texture, like that. Then we can just use them in here. Perfect. And then we need to enable the texture coordinates here. So we can copy and paste this. So enable textureCoords, and this will take in the textureCoords attributes. And this is actually a 2D vector for each texture chord. Then we want to go into our vertex shader, and we're going to do a lot of different things here. So the first thing is that we need to import or take in another attribute, which is going to be a vec2, and it's going to be called textureCoords. And then we want to get rid of some stuff as well. So we're going to get rid of this, because we're going to take this in straight into the fragment shader instead. And we're also going to do that for the light color and the light ambient. And then we'll just use the new location, location.transformation matrix here. And for the light position, we're also going to use a location light position like that. And then we'll create a couple of functions here now instead. So vec4 get world position, So this will return locations.transformation matrix, and we're going to multiply that by a vec4, and this will be the location.position, and then 1.0. Then we're going to create another one called vec3 get surface normal, and this will return the locations.transformation matrix again, and we're going to multiply that by another vec4, and this will be the locations.normal and 0.0, and then in the end we want .xyz, and of course we need to add a parenthesis around all of this like that. Then we're going to say that the vec4 world pos here is going to equal to this function instead. So we're just dividing our code a bit so it makes everything easier to debug and stuff like that. And then the surface normal, we're just going to do this here as well. And then we need to take the light position location here instead now, like that. And the GL position will be equal to the world pos. So that is really good. And then we also need to pass the texture coordinates to the fragment shader, because we're actually going to sample our texture inside of that shader instead. So create a new varying vec2, and we're going to call this pass textureCoords, and we're just going to set these to the attribute that we're getting in here in the end of the main function. Then inside of our fragment shader, we're going to do some changes as well. So we're going to take in a varying vec2 pass textureCoords here, and the surface normal will be there and the light vector as well, but these will not be varying anymore. Instead, we're going to import them or upload them using uniforms. So first of all, we need a sampler 2D to sample our texture, and this is the location.diff. Oh, we're actually not have imported that yet. So import locations from locations, and now we can use it. So locations.diffuse texture. So this is a built-in function that allows us to texture or extract data from a texture basically. Then we want the uniform, it's not forms, it's uniform int locations.has diffuse texture, because we want to be able to distinguish if it has a texture or not. Then a uniform float locations.light ambient, and then another uniform vec3 locations.light color. So instead of passing them from the vertex shader to the fragment shader, we're just using them directly in here, and name that correctly. Then we'll create a new function here, and we're going to call it vec4 get diffuse texture. And inside of here, we're going to create an if statement. So if locations.has diffuse texture, if that is equal to 1, then we want to return an inbuilt function called texture2D. So we want to texture our locations.diffuse texture, and we're going to sample it at the texture coordinates. And if we don't have any diffuse texture, we just want to return some base color here for our object. So 0.4, 0.4, 0.4, and 1.0. So that's good for now. Then we'll create another function called, and it's going to return a float and dot. And this will create the unit normals here, so we can actually just copy and paste this and remove that. And then want to return the dot product. We can actually return this like that. And then we can remove this. And then finally we want a final function called diffuse lighting, and this will calculate the brightness here. So we can take this, and then we want to create a locations variable here, so light ambient, and this n dot here is actually going to refer to this function now. And then we want the brightness, and we want to do this instead now, so we're going to return a vec4, and this will have the locations.lightColor.rgb, and that is the thing we'll multiply with the brightness, because we don't want to multiply our alpha component with the shadow or the dark spots basically. And then finally here in the main function we'll just say that glFragColor is equal to the getDiffuseTexture function multiplied by the diffuse lighting. Now we need to go into our GL commander, and we're going to add some functions here. So create texture, this.gl.create texture. We want to be able to bind the texture. This.gl.bind texture, and the first argument is this.gl.texture2D, and then the texture. I'm saying texture a lot, it's annoying. And then we're going to create another one called active texture, and this will call this.gl.active texture, and the first argument is this.gl.texture0, so index 0, and then we're going to add the texture to that. So if we set the active texture to 1, it will be 0 plus 1, and then it will be the active texture 1. Then we need another one called define texture, and this takes in the image object and calls this.gl.textImage2D, and inside of here we're going to throw in a lot of things. So the first one is the texture2D. I can just copy and paste this so we don't misspell anything. Then we want a 0 for the level, which is basically how much quality do we want. We need this.gl.rgba as an internal format, and then we want to enter this twice here actually, and then we're going to tell it what kind of data it is. So this.gl.unsigned byte, and the final argument is the image. Then we need a function to define the dummy texture. Define dummy texture. So this.gl.textImage2D, and this is even more parameters. So this.gl.texture2D, and we'll throw in a 0 again, and this.gl.rgba. Then we're going to set the width to 1 and the height to 1, because this will only be 1 pixel, and then a 0 as the border, and then this.gl.rgba, and then this.gl.unsigned byte again, and then finally we're going to create a new uint8 array, and let's just create a array looking like that. And then if the texture is a power of 2, then we'll call this.gl.generate map, and a map is basically, let's see here, map, and that is basically the level of detail of your image. So if you're really far away from your object in the scene, then you'll get a lower quality resolution image to make everything more efficient basically. This.gl.texture2D, and then texture no power of 2, and this will take in 3 functions. So this.gl.text parameter I, and this will call this.gl.texture2d, and then this.gl.texture wrap texture wrap s. So that is basically the x-axis. So we want to wrap the x-axis of our texture to the edge, and that is what this final argument here will say. So this.gl.clamp to edge. Then we can copy this and just replace the s with a t, like that. And then finally we want to add a min filter here. So min filter, and that will be a linear filter. So that is basically our thing to do the MIP mapping if our texture is not a power of 2. Now let's go into our init file again. And first of all, inside of the cube file, we're going to copy and paste this that I'll include in the description. So these are the texture chords, and we just need to export them. And then inside of here, can make some room and create a new const called textureCoords, which will equal cube.textureCoords. And then we'll throw in these into our model type. Then we want to import our material that we just created. So import material from materials/material, and let's create it here. So material is equal to a new material, and then we actually need a image. So I'm just going to add this to my project here. So let's see, copy and paste this inside here. Let's just create a new folder here called resources, and we can just paste it in here. So now I want to load this this image we just created. So material.add diffuse, and then we need to pass in the require, and then we'll do resources/testimage.png, and then we need to call the model type add material. So therefore we must create a variable of this, or a constant. So const model type is equal to this instead. So we've registered that there, and then we can call model type add material, and we're just going to throw in this here, and now we should be good to go. So if we open up our browser, you can see that we have some kind of an error here, and thanks to our compile status check here, we can now go back into our code and correct this. So I think it's inside our vertex shader, and we've forgotten a semicolon here, and now that error is gone. But we need another check here, because the upload int method does not seem to exist in our GL commander, and no, it does not. So we need to create that as well. So upload int, so the location and the value, this is a uniform 1i, one int, and then location and the value. And we haven't done this for the bool either, so upload bool, upload bool, this.gl.uniform 1i again, but instead of the value here, we're just going to check if the value, then a 1, otherwise a 0. And then finally, I've made one additional error, and that is inside our model type. I did not rename this. I did not use this here correctly. I used the same function twice. But now if we open up our browser, you can see that we have a fully textured cube, which is pretty awesome. So I hope this was useful, and I'll see you next time. Subscribe if you haven't done that already, and peace out. Bye.